1 2 1 2 test test test. Sounding nice and clear. Hi everybody, welcome to the live stream today. It's a beautiful Wednesday today. I'm streaming from the Mojave Desert in Southern California. My name is Raphael Malikian. I'm a clinical AI architect and self-taught builder. And I go live during my workday to share my progress with the people, to build in public, and also to share my insights and my commentary on current events. And I'm also going to talk today about today's Healthcare AI Daily episode, which is a very important episode from a peer-reviewed article, which is a report regarding a AI-based system for assessing intracranial hemorrhages and how radiologists have responded to that system. Some very not many surprises there, but it's good to know have a finger on the pulse to get an idea of what the lay of the land is with regarding other healthcare professionals in the industry. And the goal for today is also going to be working on the ClaimGuard system, which I've been building, which is a proof of concept AI-assisted medical insurance denials processor, which also helps healthcare professionals generate appeal letters as well. So the goal for today, once we're done talking about today's Healthcare AI Daily episode, is to actually train the large language model, which is going to be a student model, using synthetic appeal letters and synthetic denial letters to create a student model from Qwen 4B MLX. This is going to be done on Apple Silicon to train the model. So let's see how that goes. Hopefully it's not going to eat up too much of my PC or my Mac, because it should be using the GPU, which is currently not doing very much. And we'll see how that goes. It's going to be an exciting stream. Definitely pretty vulnerable of myself to kind of attempt that live on stream, but we're going to be debugging it as we go along. So if you're not doing so already, please do like and subscribe. This is a new channel. I have been posting a healthcare article daily, and also Healthcare AI Weekly, which is a journal club format every Friday. So if you're interested in healthcare, artificial intelligence, and the intersectionality between the two. Is intersectionality a word? I don't know, but I'm going to stick with it. If that floats your boat, you found the right place. Like and subscribe, enable notifications so that you can stay abreast of when I go live. I'm going to jump over to my other screen and we can get started. So I hope everybody's having a good week. I don't identify with hump day. I think every day is a gift that's to be treasured. But let's jump into today's Healthcare AI article, which is titled, Radiologists Do Not Fully Trust AI for Intracranial Hemorrhage Detection.
Welcome to...
And this is from JMIR Human Factors. Let me just duck out my camera for a second. So this is from JMIR Human Factors, brand new publication, released 2nd of June 2026. So it came out yesterday. The title is Radiologist Perceptions of an AI Tool for Intracranial Hemorrhage Detection in Teleradiology, a cross-sectional survey study. And this is by Delgaizo and colleagues. Now, what this peer-reviewed article has done, the authors surveyed 65 radiologists using an FDA-cleared AI tool for detection of intracranial hemorrhage. The question they asked, the hypothesis was, how do frontline radiologists actually perceive AI-assisted triage in real-world teleradiology? The answer actually showed a trust gap, which is relevant to anybody who's in the healthcare field or is interested in the application of artificial intelligence in a healthcare setting. The study asked them, it started basically surveyed the radiologists in this network. They used a CINA version 1.0, which is the FDA tool used for intracranial hemorrhage detection on head imaging. And the survey looked at a number of different factors, including the perceived reliability of the tool, the burden of the tool providing a false positive, the impact that the tool had on the workflow of the radiologists, and also, very importantly, or quite importantly, obviously, any concerns regarding medical legal aspects of it. Having a look at this graph to the right of the screen, which was lifted from the article, we have blue. The blue bars are neuroradiologists, and the orange bars are non-neuroradiologists. So there was actually a split here. The radiologists who are specialists in looking at neurological scans, and the kind of generalist the general radiologists. So how many people agreed? We can see there is, looking from a kind of bird's eye view, we can see there is some agreement here where do they trust the AI when it agrees? So both the non-neuroradiologists, well, that's a mouthful, and neuroradiologists agreed. Now, unfortunately, I don't have a confidence interval here to see how statistically significant the overlap might be, but we see it's roughly similar. Now, where are the differences? False positive review time outweighs the benefits. There was a strong agreement among neuroradiologists that the time spent to review false positives outweighed the benefits of the system. And there was still there was some agreement with the non-neuroradiologists, but not as much. Looking at, do the radiologists, whether they're neuroradiologists or non-neuroradiologists, do they trust the AI report when it conflicts with their diagnosis? 0 of the neuroradiologists trusted the artificial intelligence system when it conflicted with their diagnosis. But 5.8 of non-neuroradiologists trusted the CINA system for detecting intracranial hemorrhage when it conflicted with them, which is interesting. So they deferred to the FDA cleared tool when it went against their assessment. What proportion of radiologists recommended continued use for the intracranial hemorrhage detection AI-based system? 21.7% of neuroradiologists recommended continued use, so that implies 80% of them didn't. And exactly a third of non-neuroradiologists recommended continued use. So again, 2/3 possibly didn't. And looking at these numbers, for the neuroradiologists, the majority of their opinions were having a negative view towards the system. Now, for the radiologists, how much scrutiny did they apply if the AI tool was negative? 0 of the neuroradiologists were less skeptical if the AI was negative, whereas 9.5% of the non-neuroradiologists agreed to apply to have less scrutiny. So, the headline findings. Only 18.5% found false positive alerts acceptable, which makes sense. Alert fatigue is a real thing. I don't know if anybody watching or listening has a Ring camera or one of those type of tools. My Ring camera has so many false positives. It's ringing off, giving me the bell alert when nothing's happening, the wind blows, or there's a cat walking into the camera, and it's a burden. I get burnt out, and the amount of false positives I get in just my personal life is crazy. And it kind of burns you out from taking the signal very seriously. It's a lot of noise, and that has a problem, because then when, God forbid, somebody ends up breaking into your house, or if there is an emergency, it's almost like the boy that cried wolf situation. You just neglect it because this is just a false positive. Now, in a healthcare setting, that's much, much more significant. We need to have a high sensitivity and a high specificity. So radiologists from this study do quite rightly state that they see these false positive alerts as a real burden. And when I was working in healthcare, which is using mostly systems like Epic or Practice Fusion or Allscripts, I wasn't overburdened with alerts, but when we were running a busy census, if there were a bunch of alerts when you were opening a patient chart, because you're ducking in and out of the chart quite a lot during your day when you're working, especially in a hospital setting, where you're making lots of orders to a chart. Sometimes you just kind of click through the alerts and alert that burden, notification burden is a real thing. So trust, going on to trusting the system, it's very conditional. When the AI agrees with the neuroradiologist or the non-neuroradiologist, about 50% of them trust it. But only 3% trust it when it conflicts. And this is dangerous, that you could find yourself in an echo chamber of using an artificial intelligence tool, where when it agrees with you, you're happy. And when it doesn't agree with you, you say, oh, this is no good. This is an area for more discussion and more research. But only 32%, about a third, agreed that the artificial intelligence tool correctly identified most intracranial hemorrhage cases. And looking over to the data on the right, 18.5%, as we discussed, found false positive alerts acceptable. 50.8% trusted the artificial intelligence tool when it agreed, but only 3% when it conflicted. And as we discussed on the previous slide, 52.2% of neuroradiologists said that the false positive time outweighs the benefits. So what's the reality for this kind of workflow? Well, trusting systems, especially new systems, is conditional. And like I discussed, 50% of the radiologists trusted the system when it agreed with them, but a lot less trusted it when it conflicted with them. So only 10.8% of radiologists reported reduced interpretation time when using the artificial intelligence tool. They found that the amount of false positives and the amount of time having to spend reviewing false positives outweighed the benefits, which was the primary endpoint of the study. Only 6.2 radiologists reported reducing their scrutiny after an AI negative result, which is good. It shows that the radiologists are vigilant. They're not deferring their clinical opinion to an automated system just yet, and they're not relaxing based on this study. Now, neuroradiologists versus others, we discussed this on the previous slide. This makes sense. Neuroradiologists were obviously much more critical than non-neuroradiologists. 52% of neuroradiologists said the false positive time outweighed the benefits versus 23.8% of non-neuroradiologists. About a third of all respondents worried about legal vulnerability when overriding an AI alert. Now, this is a really important point for discussion. As I'm sure everybody knows, in the digital world now of digitized medical records and electronic health records, pretty much every keystroke, every click, every move of the mouse, I would imagine, is being logged. And if there is a medical review following some kind of medical issue that goes to review for some kind of internal administration or medical legal review regarding patient care, if there is an audit trail that shows a provider overriding an AI alert because based on their medical opinion there was a false positive, this raises this could have a huge ripple effect, not just on the patient, but also on the provider, on the department, and also on the local institution, and also could have a ripple effect on other institutions as well, in addition to the actual AI tool. So what are the main issues here? Alert fatigue is very, very real. There is a desire for confidence scores. I mentioned that as well. There weren't many good bars here to see were these numbers statistically significant, and definite calls for better calibration of the AI tools. So In summary, a few caveats. This report is a cross-sectional study in one teleradiology network. This is not a multi-site deployment trial, so you have to be cautious with the results because every institution varies from site to site. So the findings here are not necessarily going to be able to be transferred or applied to other institutions or institutions in other locations. But the governance signal is very, very clear here. There is a burden of false positives and alert fatigue, and trusting the AI system when it disagrees with the physician's opinion is a clear barrier to adopting. So if you found that helpful, please do like, subscribe, and enable notifications. This will notify you every morning when a new daily Healthcare AI Daily episode is released. And keep an eye out on Fridays when I release the Journal Club, where 2 peer-reviewed articles are reviewed. I review one main article, which is major for the week, and also a sleeper article that you might have missed but still has important findings and learning objectives for individuals and stakeholders in healthcare AI. So that was today's article. Now I'm going to move on to talk about ClaimGuard, which is the proof of concept platform I've been building. This is a artificial intelligence driven tool to help individuals navigate medical insurance denial letters and also to help with appeal letters. So the goal for today is training a student large language model from an existing teacher large language model, and doing this on an Apple Silicon computer. And there is a 900 pair set of synthetic computer-generated denial letters paired with a matching set of synthetic computer-generated anonymized appeal letters as well to train the model. So we have the to-do list here. We'll just run through this and then we'll do this live on the stream. It should take about an hour or so if everything goes well. This is an M1 iMac that I'm using, so we are somewhat limited by the constraints of the hardware, but the goal for this project was not to have this system running on a state-of-the-art top-end PC. I actually specifically wanted to have a small large language model that will be as trim as possible, just focusing on medical appeal generation and the processing of the actual denial letter, so that this system could be scaled and distributed to perhaps rural areas or areas where they don't have such a high budget for compute, to allow this to be disseminated more widely. Another motivation is patient confidentiality and the sensitive nature of medical insurance denials. This contains lots of confidential information, and using APIs are great, but you do have some liability of that information leaving your computer and going to a cloud, and sometimes these systems get hacked, as we know. So the goal for building this student LLM would be that this model could then be safely or relatively safely stored at an offline facility with less liability for information leaving the local environment and exposing the individuals or the department or the medical group to that liability and that stress. So the steps for today: first, I'm going to set up the MLX environment, so it's basically a virtual environment, and then we're going to download a optimized version of Qwen 3. It's a 4 billion size model, and it's already optimized for MLX, which is the Apple Silicon optimization tool, for lack of a better word. verify pre-flight passes with metal access confirmed. Then next, we're going to run the fine-tuning. This is going to be basically training the model. So we're going to do 120 iterations with a batch size of 1, 8 LoRa layers, and 720 training samples. Expected memory, expects about 10 gig of memory. Oh, I lost my glances there. What's eating up a lot of memory right now? It might be my Docker. This is going to be interesting. Docker right now is using quite a lot of memory. I might have to. I can't change my Docker setup right now because I'm using it to restream to YouTube and Twitch. But we're going to see how we get on. Hopefully, we'll be able to handle this. If the stream suddenly breaks and stops, you'll know why. So that's the goal. And then we're going to run the student benchmarks. This is all being done in Python. So basically, it looks at 10 records, measures the score, looks at how many tokens per second, compares that to the previous model. Then we have acceptance gates. We want a workflow baseline greater than or equal to 0.95, benchmark greater than or equal to 0.95, and regression less than 0.02, and then zero leaking of the sensitive mock patient information, which are on the mock letters. And then if everything goes well, I'll try and run a workflow evaluation with 10 denial scenarios, which should validate the type of denial listed in the denial letter, the route, and then also flags for human review. Let's get started. Let's see how we get on here. So we're creating the bootstrap environment. It should take about 5 minutes. So wrote runtime bootstrap report to Really? It did it that quickly? Wrote MLX runtime bootstrap to users code in ClaimGuard, LLM distill, eval. MLX runtime bootstrap report. Here we go. We fire open code. We're going to tag team in our vibe coding agent. Copy command and output. Where are you? Just copy this. Where's my plan? I had another document open here somewhere. Oh, this is it. PHI plan? No. Tuesday plan. There we go. And today's Wednesday, but I wrote this on Tuesday. So I'm going to tell the LLM implementing Tuesday plan. Did it create a virtual environment? I don't think so. Oh, it did. Installs MLX MLtrain. maybe do this in plan mode. I set OpenCode yesterday to fully auto, trying to mimic goal on codecs, and it can do everything now, even go outside the directory, which is good, but you need to have some trigger discipline. I don't know how I'm going to train a 10 gig model when I don't have 10 gig of memory free right now. Okay, that's good to know. I see what the problems are now. We have some things blocked. What's the deal? Yeah, it didn't download the, you didn't download the model, man. The initial training days was actually pretty good. The benchmark scored 96.67, averaging about 12 tokens per second. I'm pretty happy with that, considering this is an M1 iMac with just 16 gig of memory. To plan train commands, MLX LoRa model, This is the Qwen 3 model, train on the data. LLM distill scripts directory. Adapters. These don't exist. The synthetic data hasn't been created yet. The MLX distillation pipeline is well prepared but not yet executable in the current session. Here's the status of each gate. The MLX server is not running. Okay, we can start that. Ready. Seed fine-tune. Training allowed false. Metal GPU is not accessible. Come on, man, open up the GPU. Where's my activity monitor? It's not showing GPU. GPU processors, here we go. Put this in the top, right? You can watch it burn up. Not burn up per se, but it's going to get pretty hot. You know, yesterday I was working, it was such a nice day here in the Mojave Desert, and the sun was just beaming through the window and was like all over my face. And the problem is when my computer's by the window, and sometimes it gets pretty hot and the computer starts slowing down when the sun is hitting it. I have to close the window, but then I don't get a nice breeze. To unblock the pipeline, you need to start MLX. I want to run this myself so that I learn. I don't want everything to be totally automated, because that's good kind of speed running stuff, but I don't learn along the way. Step 1. Bootstrap is effectively done, but that's misleading. The training data is ready. The readiness order reports Metal GPU is not. Okay, so run synthetic fine-tune 1. I'm in the virtual environment, or I'm not in the virtual environment. Let's get in the right virtual environment first. Was that command? No, that command wasn't using the virtual environment. So first we're going to do running synthetic 900 fine-tune. see if this works. Done. Okay. 2. Run base and student requirements. Something's wrong. There should be more. Did it too quickly. Fine-tune never ran. It was blocked by a pre-gate check. Let me dig into the blocker. Yeah, it was something to do with the metal GPU. Fine-tune never ran. It was blocked. Unless it's running in the background right now. I'm going to grab some coffee, folks. I'll be right back. I might get a snack as well. Been having my morning yogurt. Gonna let this think and I'll be right back. Okay, we have a root cause. Fine-tune never ran. It was blocked. The production corpus evidence check. Report is false because no private NFM. Data is synthetic. Let that run and I'll be right back. Oh, it's actually running it. That's cool. No smoke coming out of the machine yet, so everything looks good. But the GPU is obviously maxed out, which is what I want. My vibe coding snack for the start of the stream. Got the good Activia yogurt with the probiotics. Strawberry and black cherry flavor. Black cherry yogurt has always been my favorite ever since I was a kid. Got some coffee as well. Last night I ate really late. I made a hamburger at home with some of my dad's sourdough bread, and I was trying to cook some onions with it, and I ended up burning the onions, so the patty kind of absorbed some of that charcoal with the soot from the onions, and my body's still digesting it. So this process Could take as long as 45 minutes, so we're just going to sit here and nurse it. Just make sure it doesn't hit any errors or any roadblocks. Oh, camera back on. Not a bad idea to live tweet this. I say tweet. Do we live X these days? Live exit? Say here close Chrome, so I think I'm going to close Chrome just to preserve some resources for the system. Not doing anything that needs Chrome really. We are live streaming at the same time. That is quite a burden on the machine, but doing what we can. GPU in the top right, nice and redlined. GPU here. Let's see what's using a lot of GPU. OBS, of course. OBS is eating half my GPU because I'm live streaming this, so might take a little bit longer than 45 minutes, but that's okay. You know, I've been using this Xiaomi, I hope I'm pronouncing that correctly, Mimo model on MIMO 2.5 Pro. Actually pretty impressed with how it's taking most of the stuff I'm throwing at it. I do see some differences in how it reasons and some of the decisions it makes compared to ChatGPT 5.5. Like comparing codecs and open codes, it's not really apples to apples, but it's getting things done for me. It made a few mistakes here and there, but the thing I'm most impressed with is how well it works with Hermes, with my agent. I'm really not noticing any difference between running Hermes on Mimo 2.5 compared to GPT 5.5. They both work really, really well. I'm still able to do all the things I was doing with 5.5 on Mimo. You name it, video generation, marketing emails, API integration, cronning jobs and things like that. I know it's not crazy script work, but I thought I was going to hit a big roadblock, but as the transition process has been really smooth. And you know, the most important part is the cost of the actual subscription is really very manageable. Instead of $100 a month for the subscription for ChatGPT Pro, it was 5% of that. Actually, no, it was a penny. I paid 1 cent for, I don't know how many tokens they gave me, 38 billion tokens or something like that, or 38 billion credits. So that was nice. Bring this here. Maybe if I close my OBS so I'm not monitoring it, that might free up some of the GPU to be using to just to be running on the fine tuning. So if anybody's watching, my name is Raphael Malikian. I'm a healthcare AI builder. I'm self-taught. I have 20 years of domain experience in the healthcare field between the United Kingdom and the United States, including work as a family medicine physician, though I'm not currently practicing, and also bootstrapping a direct primary care clinic startup a couple of years ago. And I'm just sharing my process here, building in public, live streaming my vibe coding sessions during my workday, and also publishing Healthcare AI Daily, which is a daily peer-reviewed article bridging healthcare AI, and Healthcare AI Weekly, which comes out on Fridays. So if you find this type of content interesting, or if that's what floats your boat, please like and subscribe if you're not doing so already. I love reading comments from viewers to see where other people are at and what their thoughts and perspectives are regarding this field. Had a good comment last week from a viewer who said something along the lines of, AI should never tell somebody when they should get a certain healthcare procedure, or it should never be used to make healthcare decisions or clinical decisions. Which I respect. I totally respect that, and not everybody has to adopt this technology. It should be opt-in. But I also added to their comment, I said, that's a really good point. I also think more concerning would be the weaponization of these tools to actually deny people care or deny populations care. So if you're watching this and you have a question or a concern or a comment, please do comment. I'd love to hear from you. My contact information is in the description box below. And if you have a healthcare problem or a pain point in your current process, and you'd like help with it, or you'd like me to help you plan out a solution, please reach out. I'd love to collaborate and see what issues you're having, and seeing how I might be able to help you with that, or talk more about it, brainstorm it. So the training is just hopefully ticking along. So not much CPU activity. What's happening with memory? Okay, here we go. Python right at the top. Using 8 gig of memory. That's what I was hoping to see. So there's clear signs that the script is working, because Python is using a lot of memory and trucking along there. Not as much on the CPU side, which is fine, or the GPU side, but the max we have unified memory, so memory and GPU are kind of interchangeable, but I did think it would be using more GPU. I can see it's doing something, which is good. So we'll let this keep ticking along. Have some good articles coming over the next week. I can tease those for you now, so you can prime yourself for what's to come. pull up my my manifest. So articles coming up. We have a mental health article from JMIR Mental Health, which is a privacy-preserving local LLM for detection of self-harm. This is an NHS article. There's another article from JMIR Formative Research going to be coming up in the next couple of days, which discusses a large language model chatbot for self-management of osteoporosis, so keep an eye out for that. There will be a discussion about an article titled LLMs in Patient-Reported Outcome Measure Development from Journal of Patient-Reported Outcomes. This looks at a human in the loop roadmap for using LLMs in development, with discussions about risks and governance by design. And then another article that I'm prepping to come out is going to be confidence metrics in multimodal LLMs for ultrasound. This is from JMIR as well, and it actually benchmarked GPT-5, Claude 4.5 and Gemini 3 Pro on 94 different ultrasound cases, and using a weighted score as a confidence estimator across all the models. So keep an eye out for those. They'll be going live in the mornings Pacific Coast time. So please enable notifications and subscribe. Hit that bell so when they go live, you can be the first to learn about the articles and watch the video. So about an hour into the stream, we talked about the first article for about 20 minutes or so. So I'm gonna just sit here, kick back, live stream the process as it happens, and we'll be nursing the student LLM training. So thank you for watching, everybody, and thank you for letting me share my process. I do get a lot of energy out of streaming, and just knowing that the work I'm doing is getting disseminated, even though the channel is in its infancy and doesn't have a big following right now. A lot of this is evergreen content, and not to be too selfish, but it's good for me to stream, it's good for me to be active, and I'm enjoying the technical aspect of this, the vibe coding, learning how to stream and manage the audio engineering, the video engineering, and the multi-streaming. So I get a lot out of this, not to be too selfish, but hopefully this is helpful for the viewers as well. Had some great feedback on LinkedIn from a post a couple of days ago. It's a comment from Stephen Thompson, who's the founder and CEO of Nextral AI. The article was talking about dataset bias in medical AI using generalized and modality agnostic auditing approach. And Stephen gave a nice comment here. Thank you, Stephen, for your comment. Pull this over to the top right. Oh, I can feel my computer slowing down now, which is good. It means we're working. Stephen says, great insights. It's fascinating how AI can sometimes take the scenic route to accuracy, just like my attempts at assembling IKEA furniture. Kudos for the team for spotlighting the crucial role of dataset bias audits. Keep the knowledge flowing. And I couldn't agree more. The summary from the article by Drankow and colleagues in NPJ Digital Medicine was that in a healthcare setting, it's important to know not just that the model has formed an opinion or made an assessment, it's also important to know why, because very often models can look accurate, but actually they may be taking shortcuts due to biases in their data set. So this is a risk for large scale deployment. And I'm respecting the peer review process. I'm not doing a deep background check into what the personal interests or conflicting interests might be of all of the authors. I probably should dig deeper into that, because some of these articles could definitely could have conflicts of interest either for or against certain AI models, the models that they might be choosing or the versions that they might be excluding. Always something to consider in our competitive landscape. But right now, I'm just presenting the work as it's been published, and if there are any patterns or anything that emerges, they'll be acted on appropriately. Something commented earlier that it wasn't accessing the GPU. Is that true? As this is cooking, let's do some learning. You know, what's helped me with my learning AI stuff is explaining things or learning things in a way that uses medical analogies. Really helps me. That's something I use in my clinical practice. If I was talking to a guy who was a carpenter or understood carpentry, could explain joints in terms of hinges and things like that. Or a common analogy when I was working in orthopedics was the analogy between cartilage wearing down and the process of osteoarthritis being described in the context of the tread on your tires wearing out based on how you drive and how old the tires are, and that's something that worked really well. So I was struggling with some concepts, especially concepts which are new to me. This is a new pivot for me to move into health tech. So I had a tough time learning some of the Python libraries like NumPy and Pandas and Scikit and XG boosting, and trying to remember like exactly what they did and why they did it and how they did it. So I asked Google Gemini to explain these to me using medical analogies, and it really helped click. One of the examples it gave me was that NumPy is like a nurse giving you the vital signs on the patient, and XGBoost is similar to a conference of specialists to evaluate a complex case and talk about it. So I thought that really helped me. So as we're waiting for this to run, for the training to go through, I'm going to go through the Tuesday plan. Where's my Tuesday plan? It's gone away. Tuesday plan. So what happens here? Bootstrap the MLX environment. Help me to understand the LLM below using medical let's see what Xiaomi comes back with. This will be interesting. So we can learn together while this is cooking. I had a feeling it was going to be doing that. So, bootstrapping the MLX environment. This means setting up the MLX machine learning framework, which is Apple's ML library, machine learning library, with all of its dependencies, so it's ready to run. And this is like prepping an operating room, sterilizing instruments, positioning equipment, and checking all systems before surgery begins. So that was the step that was done here. I know what a virtual environment is. A virtual environment is basically like a compartment. Let's see what how Xiaomi would explain a virtual environment using a medical analogy. Medical analogy. Creating .venv is like setting up a dedicated, isolated surgical suite with its own equipment and supplies. It won't contaminate or interfere with other procedures happening elsewhere in the hospital. The MLX designation indicates this suite is specialized for MLX procedures. And sorry for any, I'm not apologizing for any noise. I'm really lucky. I live right by Edwards Air Force Base, and NASA is literally over there. So during the day I get to have the most amazing test flights and air traffic where I live. It could be worse. I could be next to an actual commercial airport. What would an analogy between downloading this? What's the medical analogy of downloading the Excuse me, sir. The medical analogy of downloading Quen 3. This would be like downloading Harrison's Internal Medicine. Downloading Quen 3 is like bringing in a specialized surgeon to your prepared surgical suite. Quen 4B is a specialist name credentials. MLX indicates they've trained for your specific equipment, and 4-bit means they use minimally invasive techniques but the same expertise, requiring less resources and space. Isn't this great? So how would we explain running a synthetic fine-tuning? Why is this happening? Maybe I'm clicking in the wrong place. Oh, my computer's definitely slowing down now, which is good. A lot of memory pressure. Not totally redlining it. But that's okay. Medical analogy. Running synthetic 900 fine-tune is like training a resident using 900 simulated patient cases before they work with real patients. Fine-tune means taking a general practitioner, the pre-trained model, and giving them specialized training in a particular field to make them better at specific tasks, like turning a general surgeon into a cardiac specialist through targeted practice scenarios. I like that. How would it explain this script here? Let's move this to the left. Medical analogy. This command is like running a specialized training program for a resident. The manifest file is the curriculum listing all 720 training cases. The output file is where you'll document the training results. The MLX LoRa executable is your specialized training equipment. The parameters translate to 120 iterations is equivalent to 120 training sessions. Batch size of 1 means 1 case at a time. 8 LoRa layers indicates 8 specific skills being refined. 10 gig of memory, look at this. The procedure requires 10 units of operating room capacity. Your iMac has 16, so there's headroom. Close Chrome or memory-heavy apps. Free up operating room resources before the procedure begins. And actually, I opened Chrome to look at the comments from LinkedIn, but I'm going to close it now. And I see my computer is slowing down just so nicely. So what's the next step going to be doing from a medical analogy? Medical analogy. Running base plus student benchmarks is like giving both the experienced attending physician, which will be the base model, and the newly trained resident, the student adapter, the same 10 patient cases to diagnose, then comparing their accuracy, the time to diagnosis, which is the latency, and how many findings they can process per second, tokens per second. It's a standardized exam to measure how much the training improved the resident's skills compared to the attending. Then we have an acceptance gate. This is going to be like the passing score for the exam. Medical analogy. The student acceptance gate is like a final board certification exam for the resident. Before they can practice independently, they must demonstrate a workflow baseline greater than or equal to 95%, which means following standard medical procedures correctly. Benchmark greater than 95%, which means diagnostic accuracy at least 95%. Regression, no more than 2% decline in any skill area. And 0 PHI findings, and this means perfect patient privacy compliance. The student acceptance report is their certification documentation, proof they pass all requirements and are ready for independent practice. How do we describe the workflow evaluation using medical analogies? Running workflow evaluation is like a clinical simulation lab, where the resident handles 10 complex patient cases requiring multiple steps, diagnosing the condition, determining the correct treatment pathway, knowing when to call for a specialist consult, testing their ability to manage complex patient journeys, not just individual diagnoses. Very cool. Want to check on my phone how the stream is performing with all this stuff going on, because I can see myself on OBS, but I don't see what the viewers are looking at. Let me just mute myself for a second and pop over to my phone. Okay, it's lagging a little bit, a couple of dropped frames, but not a big deal considering the importance of the work that's being done. So I can deal with that. I'm sending this command. I hope I'm not going to break everything. It might break it. I'm not seeing much activity on the GPU at all. 3%. Maybe that's enough right now. I just want to make sure it's working because earlier on it didn't have access. Gonna take a quick break, go chit chat with my dad for a second. I'll be back in a little bit, folks. Let this cook along. what's happening? I see movement. What's going on here, folks? Maybe I shouldn't have typed this. I think I interrupted the process, but that's okay. Ready false, training attempted false, training succeeded none, blocked reason, production corpus evidence report not ready for training run. Metal available true. Metal GPU is available, but the report wasn't updated. The script timed out without writing a new report. We're expecting that. This might be a long stream, but it's all good. Pre-flight passes now, ready true, no blocked reasons, the data tier fix works. Now running the actual training. Let's go. Oh, there was a little, the GPU breathed for a little bit right here. So go, okay, let's go back. running. So that's cool. So that's cooking. What's happening over here? Starting the surgical procedure. So we're doing the surgery, folks. The previous run timed out. I don't know if it timed out or if I interrupted the surgeon, and I think I put my hands in the surgical field by accident because I wanted to ask a question, which I've done before when I was in training. Nothing more like medical studenty than asking a question during surgery, during critical points. You mean well, you're keen, you're excited, you're nervous, and you get that nasty look, like, what are you doing here? Who sent you? Actually, most surgeons I've worked with have been really cool, very nice people to learn from. Got timed out. Time out like the patient no-showed. Yeah, today is for me a normal day. It's a beautiful Wednesday. going to be about 94 Fahrenheit here today, so enjoying the calm before the storm, before the weather gets really hot. But my poor cats, they're at the shelter today to get neutered. My dad dropped them off this morning. I'm going to pick them up later on. And so it's a responsible part of having a domestic cat is spaying and neutering them. So it's not something that's intensely emotional, but just an important part of, I suppose, being a responsible owner. There we go, GPU. I like that. Maybe that was there before, but I didn't see it. Almost feel like hooking up another capture card and playing some video games while we're waiting for this to render, because I can't run it on my computer right now. It will eat up too much of the too much system resources, or would it? I might be pushing it. It specifically said, close background apps, don't have anything open while you're doing this. And I'm sitting here thinking, yeah, let's open let's play some Call of Duty. But maybe with a capture card on, it might work. Too much work right now. I've got a stable setup right now. I don't feel like designing my OBS scenes right now. Just gonna babysit this and watch what happens. gonna make a PB&J and use this downtime to clean my messy office because I've got stuff everywhere. I'm gonna tidy up a little bit, make some good use of the stream. Be right back. Oh, Python quit. That's not good. Training failed with a metal GPU error. The GPU command buffer execution failed due to impacting interactability. This means that the system's GPU is overloaded, likely by Chrome or other apps. No, Chrome is not open, but what about OBS? Close Chrome and other GPU-heavy apps before running. The memory is shared with some CPU and GPU. Chrome can eat into GPU headroom. Wow. So maybe live streaming this isn't going to work as well as I had hoped. It's OBS, because I'm using the hardware to encode the video. What should we do? Option 1, add grad checkpoint to the training command. Reduces GPU memory pressure by about 30%. It's 10% slower but keeps OBS running. Reduce the number of layers from 8 to 4. Pause OBS during training. Let's try 1 and 2. I was expecting some hiccups. And we did capture them on live stream, so it just goes to show what can go wrong. Or the problems you can encounter when training large language models on a system and also using it. But I really want to stream this, so we're going to make some changes and see if we can solve it. Might be a longer stream than usual, but this is giving me an opportunity to tidy my office and among other things. So it's running now. Let's see what happens. It's okay, let it run. Start a new chat. Let's see what the error was. Got this error while training the model. Big error here. What's nice is Mimo has a million context of 1 million. So you can review a lot of code before having to compress it. So we're cooking again. You see the GPU is nice and full. Not full, but as at full capacity. What if I change the encoder for the stream to CPU instead of GPU? This is a metal GPU crash during MLX computation. GPU command buffer failed, causing signal abort. Let me find your training script to recommend a fix. Okay, you don't have to do that. We have a fix. Okay, so lesson number 1: don't live stream in OBS while you're training a large language model on a small M1 Mac. All right, lesson learned. Gonna let this run and do some tidying up. babysitting the model right now. Hoping this will go through without an error, which would be nice. So far, just ticking along. Looks like a command came back and I missed it. So the issue here was the report was updated, new settings ran, but still hit the same metal error. The validation step is the bottleneck. I wonder if the timeout is the issue. Okay, so increasing the timeout is not going to help. The issue is the GPU command is taking too long, 800 seconds of validation, which is like over 10 minutes. And then macOS kills the process. Should I pause OBS for the training run? I think I'm going to have to do that. Sad face. So that's the most reliable path. Here's the plan. Revert to 4 layers, back to the original settings, and then run the fine tune. Alright folks. I really wanted to live stream it. I suppose for this kind of setup you need a second machine for streaming, so we were still up for a good couple of hours, which isn't bad. We got to talk about healthcare AI, and we did some We did some learning along the way with some medical analogies for machine learning terms and the process. So this is a realistic bottleneck. Obviously, machine learning is a very resource-intensive process. And look at that! As soon as I jumped over to the full camera here, the GPU use almost halved. Let me pop back real quick. So look at that. You see over here, that's the GPU usage when I was on just the camera. Oops. But when I jump to my screen here, with all the different assets, the GPU really spiked. So I think in the interest of progress, interesting, there's a reflection of my curtain rail from somewhere. How is that showing? Nice reflection coming from somewhere. Anyway, folks, been great streaming. Thank you for letting me share my progress. I have no other option right now but to stop OBS. So I'm gonna close the stream. If you're not doing so already, please like and subscribe and enable notifications. There'll be a new Healthcare AI Daily going live tomorrow. Got a couple of interesting articles in the pipeline for everybody to learn about. And on Friday there will be Healthcare AI Weekly, where we'll be talking about 2 significant articles from the week which weren't covered in daily episodes. So I'm going to sign out for there. I've been Raphael Malikian. Thank you very much for following. And if you have a healthcare question or a healthcare problem that's bothering you, not medical related, but something that could be solved with technology, please do reach out. My contact information is in the video description. I'd love to talk about how I might be able to help you consider solutions to solve your pain points in healthcare. All right, folks, been a pleasure. Bye for now.